Derivative of log or exponential functions. What you're going to learn today is what if I don't have a base of e, what if I have a base of something else. And what I want to try to show you is a pattern that's very similar to e to the x and ln. And so just kind of get going. If y is equal to a of x, then x is equal to log base a. So if you want to think about it, if I have my answer, which is y, then answer is equal to some sort of base raised to a power. Then the log is going to be my power is equal to log base of my answer. So here's my y for my log. So for example, if I have a to the 1 is a, then log base a, so here's my power. I'm going to highlight it. So my log is equal to my power, so it's log base a of my answer. I'm going to underline my answer in blue. So log base a of answer is equal to my power. And so if I was going to write that in exponential form, a, my base, to the 1, power is equal to my answer. Similar, notice that my answer is 1. So a to the 0 is 1. So my power comes over here. My answer comes here. So log base a of 1 is equal to 0. They're inverses of each other. If I have a to u, it's very similar to e to the x. I'm just going to rewrite it. So if you notice right here, here's the rewrite. Here's the derivative of the exponent. But I'm adding on something new. I'm adding on that ln of a. And so I'll show you several examples, but I want you to notice the only thing that's new is it follows the same pattern of e to the x. You rewrite it, take the derivative of the exponent, but you're going to now also write ln of whatever your base is. Similarly, if I have log base a of u, I'm going to, again, remember I had that little box around the ln part. My box now still goes to the denominator, just like with the ln. Its derivative still on top, but I want you to notice that my ln of my base is now also on the denominator with my u. And so that's what we're adding. That's what's new, is you're doing the ln part. So let's go through several examples. So we're to find the derivative. So I have 2 to the 3x is equal to y. And so I'm looking for y prime is equal to, again, it's similar to e to the x. And so I'm going to underline my power in red. So I'm going to do a rewrite. So I have 2 to the 3x, not e to the x, 2 to 3x, and then I'm multiplied by the derivative of my power. Derivative of my power is 3. And the new part is I need to take the ln of my base. Well, my base is 2, so I need to multiply by the ln of my base, which is 2. Alright, find the derivative for log of cosine of x. If you don't have any number down here, then that's equal to 10. So we're going to go ahead, if you want to fill it in, this is base 10. And once again, my log follows the same format as my ln. And so with my ln, remember we put a box around it, and that whatever we put a box around goes in the denominator. So we're going to do the same idea. So we have y prime is equal to, and we're going to put that box down there again because we're going to fill it in with our cosine x. And we're going to take cosine x, take the derivative, put it on top. So the derivative of cosine x is negative sine x. But this part should be exactly what we did with ln. The part that we're adding is, what is this base? So we had that base 10. And so I need to multiply by the ln of 10 in the denominator. So what's in yellow is what is new when we're dealing with logs that are bases other than e. Number 3, y prime, and so we're going to follow the same thing. I have something raised to a function similar to e to the u, and so again with my e to the u, here's my base, here's my power. I'm going to rewrite it. So my rewrite is 5 to the x to the third plus 5x, and then I'm going to multiply by my power, except for I'm going to take the derivative of my power is going to be 3x squared plus 5. And then the part that, remember, this is our e to the x pattern. Then if it was just e to the u, we would be done. But since it's not e, my power, or my base is no longer e, it's now 5. I need to multiply by the ln of my base. So I have to multiply by ln of 5. Number 4, y is equal to log base 6 of 1 over x, or the square root of x. So let's go ahead and fix it and move square root of x to the numerator. So we have log base 6 of x to the negative 1/2. And once again, I'm going to underline my power. There it is in blue. And just like ln, I'm going to put a box around my x to the negative 1/2 because that's what's going to go in the denominator. So when we do this, so we have y prime is equal to, I'm going to move that a little bit lower, y prime is equal to, and I'm going to rewrite what was in the with my box and put in the denominator. So I have x to the negative 1/2, and I'm going to take the derivative of that and put it in the numerator. So we have negative x to negative 3/2, and then I'm going to, so far this is just like ln, and then the last part I'm going to do is multiply by the ln of my base. Well, my base was 6, so I'm going to multiply in the denominator ln of 6, and we are finished.